Hello guys, welcome to the lab 3 of this course. Lab 3 will be the fracture experiment, and we will investigate the brittle fracture of polymer specimens. Now in this experiment we will have 4 specimens, all of the same material. However, they have different dimensions and different parameters. So this is how the specimen will look like, and we will measure the length of the specimen, the length of the crack here, and the width, and also the thickness, and also the width. Now, and then we will repeat this measurement, this dimension, the measurement of 4 of those different specimens, and we will record it, and then we will move to the setup. So you can use, in this experiment, we can use basic ruler, and we will have to measure each one of those parameters for each of the different 4 specimens. Now, we already did those measurements, so I'm just going to move on to the setup. Now, in this experiment, what we really care about, aside from the parameters of the specimens themselves, we also care about the critical load. And the critical load basically is what we will do here is we are going to place the specimen here, and then we will tie it to this scale here, and then we will be pushing this up by moving those, and when we do this, there will be a force load in this direction, and it will crack. Now, everything will seem a lot more clear when we actually start performing the experiment. So let's already start. I'm going to start with this specimen, and this one here, the one that now you see, has a length of 22.4 centimeters. The crack width here, as you can see, is going to be 5 millimeters. And all of the specimens have the same thickness, which is 1.3 millimeters, and the width of each of them is 1.8 centimeters. So now we can start with the first one. Now, when I'm starting here, this is already too high. So what I want to do is I want to first make this longer. I would want to push this scale down, and I can just move the gears in this way, and then it will eventually go down. Exactly. Now, what I want to do is I want to apply the load exactly on the same location. I will align it with the crack, as you can see. So the crack is hidden now behind the rope of the load, and then I'm going to place it on the support. Now I think I should make it a little bit. Alright, so now this is the setup that you see now. I will just remind you with a few notes. Again, I have measured the crack width, the length of the specimen, and I already know the thickness and the width of the specimen itself. Now, we have it placed on the support, as you can see here, and now we are ready to apply a load on this. What we will do is this. The way that this exact setup operates is you have the balance here. So what we want to do is we have the scale here. What we want to do is we want to first of all make sure it's on, and this scale, it automatically holds a certain value. So what we want to do is we want to keep one of our teammates to keep their finger on the hold button to unhold it, and the hold button you can see exactly here. Now, once we have the teammate ready, we will start applying. The load on this. All right, let's go. So you can see it starts by 0, and what we will do is we're going to start pushing up. Now we can see the values are increasing, and these are the values. Please, yeah. So we'll have to be a bit. We have to be careful about the hold. So once the value is held, we stop until our teammate unholds this value. As you can see now, it cracked. Exactly. So here, what the value that we really care about is the value just before or just at the time of the crack. Now, during this experiment, you might want to use your phones, for example, and to record this, and then exactly figure out what number did the specimen crack at. this is the PC value. This is what we're going to go PC value, and this is what you will use in your calculations, which is the critical load. Now, I will repeat the same process, the same setup, to 4 different specimens here. So I'm going to discard this one here. I'm going to apply it to a different setup, to a different specimen, sorry. This one, the thing that you see here is, let me check again, it's 22.4 centimeters. However, it's 7. The crack is 7. The width 7 millimeters. Yeah. So I would expect this to require a lower. Load, right, for it to crack, because the crack width is much more. It's more. The one you saw earlier was 5. Now, as you can see, again, what I would want to do is to align this here. So I'm gonna take it out. I'm gonna put the scale down. All right. All right. Now, I'm going to repeat the same process that you saw earlier. Here. All right. So I make sure it's exactly in the location I want it. I make sure that it's resting on the support. And now I will turn on the scale. I will wait for it to give me a 0 value, and it does. Now, exactly, we're going to put our finger on the hold button to make sure that does not hold any value. I want to see every value, especially the time when it cracks. Actually, that is the only value that actually matters. I'm applying this fast. Now the last value again that you will see before this crack happens is the critical load, and this is what we really care about. So now we're going to repeat this for the third specimen, and it has a length of 26, and you can tell this is this is longer. It has it's longer in length, and the crack of this specimen that you see in on the setup right now is 5 millimeters. So what I want to do is I want to first expand those guys so it can actually fit on them, maybe a little bit more. All right, this seems fine. And again, what I want to do is, this is too short, so I will put this back down. All right, maybe a little bit more. So you can move those gears. You can move those gears. It depends on how fast you want to go. So I'm moving this because I'm using this because I know that the increments are going to be more, and it doesn't matter for me now. I'm just making it like, all right, here. So now you can see that it's identical. It's the same process again. So what I'm going to do is, again, I'm going to turn this on, and I'm going to wait until it gives me a 0 value. Exactly. Now I'm going to take care of the hold button. I'm going to start applying load. So it's still 0 now. It starts feeling some load. All right, I want to unhold this and keep going. And it cracked. So that's perfect. So in the same setup here, what happens is that you will see, you will record whatever you guys see on the last value before it cracks. We will use again a camera. It will be very beneficial to use a phone camera or whatever to be able to see exactly the number that the load that makes this specimen cracks. Now this is the same length, you can see, because it rests exactly perfectly on the setup with this support. So again, this is the same length. It's 26 centimeters. However, in this specimen now, the last one, the crack length is 7. So you can see there's the length of the width of this crack is more than the previous specimen, and I would expect it again to have to require a lower load for it to crack, which means it will require lower critical load, which again you guys will be using for your calculations. All right, now I'm gonna rest this here, maybe a little bit more. I do not want to start from any load. I don't want the specimen to feel any load on it because I want to record everything. All right, so okay, again the same process one last time. I'm gonna turn this guy on, I'm gonna expect someone to take care of the hold button, and I'm gonna start applying load. You can see it's 0, which is perfect because now we're gonna start, and we can see that now it starts feeling a little bit. Maybe I should be more careful about this. All right, and hold please. All right. Exactly. That's it. So here's what happened. Now we have 4 of those specimens cracked, and now I would just make a quick summary. What happened? What we did exactly today in the lab is we had 4 specimens, and for each one of them we measured the length and the crack on the specimen, how the width of the crack. All of the 4 specimens have the same thickness, which is 3 millimeters. They have the same width, which is 1.8 centimeters. However, each one of them has a different combination of width, thickness, and length. 2 of them were 22.4. Each one of them was 22.4 centimeters in length, and one of them had 5 millimeters. The other had 7 millimeters in width of the crack. The other set was again two specimens. Both of them have 26 centimeters length, and one of them was again 5 millimeters, and the other one was 7 millimeters in terms of crack width. And then I record those dimensions. I record them for my calculations, and I would want now to measure the critical load. I will put it on the setup as you exactly saw. I will apply the load, and I will keep track of the number appearing on the scale, and to see exactly the load required just at the time or just before the specimen cracks. This is the value that we will be using in the calculations.